Okay, adding and subtracting. This is going to be lecture, what are we on now? 11? Yeah, lecture 11. This is going to be operations. Zoom out. With radical expressions. Okay, so for this lecture, what we're going to be doing is we're going to be doing adding, subtracting, multiplying, and dividing. And I only have a few minutes left, so I'm just going to do one of each. How about that? Let's look at the problem sets. Okay, in the problem sets, we're going to do number 1 together. Okay, so number 1 says square root of 12 plus square root of 3. Okay, so for this one, what we do is we don't add them together yet. We only add them once we simplify them. So can we simplify the square root of 12? What would that be? 12 is what times what? 4 times 3, right? So I can break up the 12 into 4 times 3. And I'm going to underline the 4 just so you know that's the perfect square. Okay, so I can take out the 4 as a what? I can take out the 4 as a 2, right? The 3 has to stay under. And this thing on the right side is still the same. It hasn't changed yet. So now notice that I have like terms. I have like terms now. That's what I want to get when I'm adding or if I'm subtracting. I want to get those like terms. Now notice I have a 2 out in front of the square root of 3. That's fine. But what number is outside of this one? Well, if there's no number there, we assume it to be a 1, right? So I'm just going to put a 1 right here, just so the math is easy. And now we add what's on the outside. So let me change my color to blue. Circle these, just so you know what's going on. All right. Let's add the blue numbers. What's 2 plus 1? That would be what? 3, right? And then I still have square root of 3, and I'm done. So what I'm trying to do here is I'm trying to simplify first, and then I add up. Okay? Let's try a subtraction problem. Let's do number 2. Square root of 45 minus square root of 5. So what's this one going to be? I'll give you a minute to copy that down. So while you're doing that, be thinking, what is 45? 45 is something times something, right? If you think you know what those two numbers are, go ahead and put them in the chat box, because I'm going to need some help on this one. Square root of 45, what would that be? Something times something, right? Okay, I'm seeing some right answers. Good. I think there's only one perfect square that you can take out of 45. I don't think you can split it up like 32 and do 16 times 2 and 4 times 8. I don't think that's possible. So it's only going to be two numbers, but one of them has to be a perfect square, right? So 45 is what times what? 9 times 5, right? So I'm going to break up the 45 into 9 times 5. And keep this the same over here. That hasn't changed yet, right? Can't take the square root of 5. That would be irrational, not a whole number. Okay, so looking over here at the left side, I've got 9 times 5. Which one is the perfect square? Which one do I underline? That's going to be the 9, right? So the 9 can come out as a 3. It comes out as a 3. The 5 stays under. I have minus square root of 5. Okay, so now I have those like terms, just like I did before. I have like terms. And you should always have like terms when you're adding or subtracting. Multiplying and dividing is a little bit different, right? So I'm going to put the 1 in front of this square root of 5, just so you have a number to go on. And let me circle these. What's 3 minus 1? Well, that's just going to be 2, right? So I'm going to have 2 times the square root of 5, and I'm done. So that's how you add and subtract when you're doing square roots. Now let's talk about multiplying and dividing. That takes a little bit more work, but there's actually a clever formula that you can use when we do these. Okay? So let me get a brand new sheet of paper and we'll just go from there. We're going to try number 5 on the problem sets. Okay. Before we do that, let's do 2 quick little formulas. Okay. The square root of a times b is equal to the square root of a times the square root of b for a and b real. Okay? That's the first formula that we're going to use. Notice that when you're multiplying, you can actually break up the AB into an A and a B. Okay? That's only if A and B are real numbers, not if they're imaginary. We're going to look at those next week. But for right now, A and B have to be real numbers, right? You can break up that radical into square root of A times square root of B. Let me show you what you cannot do. And I've seen this before. And I cry every time it happens. Not really. But I sometimes see this. And this ticks me off. It really does. Can I do this? Can I break it up by addition? No, I cannot do that. Don't be doing that. Similarly, we cannot do this. A minus B. Can I do this? No, I cannot break it up that way. So don't be doing that. This only works with multiplication and division. Let me show you the division formula. We're going to take the square root of a fraction, a over b. Now I can do this. I can break this up into square root of a divided by the square root of b. Okay, I can do that. For a and b real, and b cannot be equal to 0, because then you'd be dividing by 0, right? So we can't let b be 0. But other than that, these 2 formulas work. These 2 do not. I'm going to put exclamation marks beside them, because these do not work. But the 2 with stars beside them do work, and we're going to be using them today. Okay? So if it's multiplication, we can break up that radical. And if it's division, we can break up that radical into a top and a bottom. Okay? All right, let's take a look at number 5. Okay. Square root of 12 times square root of 5. Okay, I'll give you a minute to get that copied down. So what can I do here? I've got square root of 12. There are two ways I can do this. I can start off by simplifying the 12, or I can start off by multiplying. Let's do it both ways. Let's start off by multiplying. So what's 12 times 5? Have you thought about that yet? 12 times 5 is going to be 60, right? So now I'm really doing the square root of 60. So let's see what that is. How can I break up 60 into perfect squares? If you think you know how to break up 60, put it in the chat box, because I need some help on this one. What can I break up 60 into? Something times something. And one of those has to be a perfect square. 60 is what times what? $60 is what? 15 times 4. That's a good idea. 4 and 15, yep. You could do that. They do multiply to be 60, right? Because 4 times 15, that is 60. Yep. Any more guesses? Are there any other ways we can do it? Somebody says 2 times 30, but none of those are perfect squares. One of them has to be a perfect square. Remember that. We're taking square roots, right? 6 times 10, but at the same time, one of those has to be a perfect square, though, so we can't do 6 and 10. Can't do 3 and 20 either, right? So I'm going to choose 4 and 15 for now, and you'll see why in a minute. Okay, so I'm breaking it up into 4 times 15. So which one is the square root? I mean, the perfect square. I've been doing this for too long. It would be the 4, right? The 4 is the perfect square. So I can take out the 4 as a what? As a 2, right? But I've got to leave the 15 under there. And I'm done, right? You can't break up 15 into square numbers, right? Because that would just be, what, 3 times 5? That's true. I mean, 3 times 5 does equal 15, but is any one of these a perfect square? No. So I can't break it up any further. I've got to leave it as this. This is going to be my final answer, okay? We're simplifying it as much as possible. We're taking out as many squares as possible, right? So I've got to leave the 15 under the radical. And I know it seems wrong, but 15 is what you call square free. 15 is square free. It doesn't contain any squares. So any square free numbers, you got to leave under the radical, right? So that's multiplying. Let's do dividing now. We're going to do number 7. And I think that's the last one we're going to be able to do today. 7 is square root of 4 divided by square root of 16. Okay, for this one, there are a couple ways we can do it. We can start by taking square roots first. I think that'll be fine. So what's the square root of 4? That would be what? 2? What's the square root of 16? That would be what? 4, right? So 2 over 4. Is that my final answer? Not necessarily. I can still reduce this down, right? I can reduce this down into 1/2. And that's really going to be my answer. That's fully simplified. Now, there is another way you can do it. We can use the formula that we just talked about, right? The one with the star up here. Let's use this one and see what happens, okay? So let's just do this another way. So I've got square root of 4 on top. I've got square root of 16 on the bottom. So what happens? I can actually make this into one big fraction. And I'm going to have a tall radical symbol like this. So I can make this into 4 over 16, right? I'm just taking the two numbers, making them into fractions. So now what can I do? I've got 4 over 16. If I reduce that fraction down, isn't that the same thing as 1 over 4, technically? 1/4. And then what's the square root of 1/4? Well, I can break that up, right? I can break this up into a top, which is just square root of 1, and a bottom, which is just square root of 4. Okay, so then what would that be? What's the square root of 1? That would be 1. What's on the bottom? What's the square root of 4? That would be 2, right? So in the end, I get the same answer, 1/2. All right? So that's how you divide using square roots. So you can add, you can subtract, you can multiply and divide. You can do all those things with square roots and cube roots, right? And do know that multiplying and dividing, they have those two formulas up here that you need to know.